All right, so this is the second, I don't want to say half, but the last couple of problems anyway, with rational inequalities that we didn't have time for in class today. So we're taking a look now at example number 6. You'll notice that, of course, these look different. They look like they are a fraction. But other than that, they're still going to have the same type of feel. We have a factor on top. We have a factor on bottom. We could have two factors on top and all the same details. And what we're doing is we're setting each of the factors equal to 0 and placing them on a number line. So this is x equal 4 and negative 3. So on my number line, negative 3 first, 4 second. Test values in each interval, right? So we'll test like a negative 4 here, 0 here, and maybe 5 over here. So if I put in negative 4, I would have on top negative 4 minus 4. On bottom, I would have negative 4 plus 3. So on top, it's negative. On the bottom, it's also negative. And a negative divided by a negative, of course, is a positive. So a positive on my number line. Let's test 0 in between. So I have 0 minus 4 and 0 plus 3. So on top, 0 minus 4 is negative. On bottom, 0 plus 3 is positive. Negative divided by positive would be a negative. And then the last one, testing the number 5. So on top, 5 minus 4, and on bottom, 5 plus 3. On the top, 5 minus 4 is positive. On the bottom, 5 plus 3 is also positive. Positive divided by positive is a positive. Okay, so considering these intervals, this says that I need it to be less than or equal to 0. So that would be negative. It does say or equal to, but we have to be careful. Normally, with polynomials, as in the last problems we've done, we would just put brackets on both ends. And I can put a bracket actually at 4, but I have to put a parenthesis at negative 3. And the reason is because if I plugged negative 3 in, I'd get 0 in the denominator. So no matter what the inequality symbol is, I can't equal negative 3. So on this one, my interval goes from negative 3 to 4, parenthesis on the negative 3, and a bracket on the 4. All right, one more example of this type looks like this. So kind of like what we were doing in the last sections with the inequalities with polynomials, or the last video, I should say. I need everything on the same side and the 0 on the other side. So I'm going to start by moving this over 4 over x. Now, I know that typically we want to get rid of denominators. We can't do that with inequalities because if I tried to multiply everything by the denominator, which is x, I wouldn't know if I was multiplying by a positive or a negative number. If it was positive, the direction of the inequality would stay the same. But if it were negative, the inequality's direction would be different. So I can't just multiply by a variable. I have to leave it in the problem. So what does that mean? Well, it means I need to get a common denominator. So in particular, I need to multiply this by x over x, because right now it's x over 1, which would give me x squared over x minus 4 over x, which would give me x squared minus 4 over x, and that numerator would factor as x minus 2, x plus 2 over x greater than or equal to 0. If I set each part equal to 0, the first piece gives me 2, the second piece gives me negative 2, and the denominator gives me 0. So I have a number line where I have three endpoints or numbers marked negative 2, 0, and 2. And we'll test a number in each of these intervals. So over here, I might test negative 1. I'm sorry, negative 3 is what I meant to say. In between here, I might test negative 1. Over here, a 1, and over here, a 3. So in testing these intervals, we would plug each of those into, and again, it's kind of our choice where we plug it in, but my favorite place would be here because it's in factored form and I only have to worry about the signs. So if I plug in negative 3, I have negative 3 minus 2 times negative 3 plus 2 over negative 3. Negative 3 minus 2 is negative. Negative 3 plus 2 is also negative. And on the bottom, I have a negative. So negative times a negative on top gives me positive, and a positive divided by a negative would be a negative. So the first interval is negative. The second one is a negative 1. So I have negative 1 minus 2, negative 1 plus 2 over negative 1. The first one's negative, the second one's positive, and the bottom's negative. So now I have negative over a negative, which is a positive. All right, the number 1. So now I have 1 minus 2, 1 plus 2 over 1. So 1 minus 2 is negative, 1 plus 2 is positive, and 1 on bottom is also positive. So negative times a positive on top is a negative, divided by a positive would be negative. And the last one is a 3. 3 minus 2 times 3 plus 2 over 3. The first one's positive, second one's positive, last one's positive, a whole bunch of positives, so we've got a positive here at the end. My interval says that I want to look at values that are greater than or equal to 0, which would mean positive. I can use brackets, but I can't use brackets on x equals 0 because that would give me a 0 in the denominator. So I'll use a parenthesis on the 0 and brackets everywhere else. So my interval would look like bracket negative 2 to 0 parenthesis, bracket 2 to infinity.